expectations that you come from the DDD community, but instead you can learn some concepts around event sourcing that are on their own enough. And from there, find success in building an application. And those, I said
Actually, you know what happened? We don't have the mic. We're gonna have to restart. So now we're.
So well.
Yeah, I know. You did well. Okay, so again, thanks for joining. Let's go back here.
We got a mic now?
You can go back one slide.
All right.
Yeah. So thanks for joining, everyone. We had no
exactly.
audio for some reason. I think it's because the screen share. The thing you shared with me.
Microphone?
I don't know if there was no audio.
Okay.
So I don't know why.
Okay.
Can someone test audio on YouTube? Actually, maybe I can check it out.
Should sing a song.
Oh, stupid Bluetooth is on. Where are these? There's always something, right? It's the first one back, so.
Yeah. Well.
Do you see it?
Testing 1, 2, 3.
No, but like on the YouTube channel. Oh yeah, now I can hear it.
Okay. So it's coming through audio-wise? I guess it's good to have the headset because you're going to feedback.
Yeah, I'm just using it as a monitor to see what the YouTube channel's like. So
Sure.
yeah.
Well, as long as it's, audible, we can hear it.
Yeah, I just wanted to also make sure I don't have two mics on, so there's no like weird reverberation.
Do I need I don't know. So
No,
if you're
I
not
don't think
hearing
you
mine,
can do
you're only
anything.
the owl, right?
I think it's coming through the owl.
Okay, good. That's a good source.
It might be through here, but I can hear you.
Okay, as long as it doesn't sound too garbled. Okay, well, we can go from the top.
I'll keep it like this.
Okay.
Okay, so once again, sorry about the audio. There was no audio at the beginning. I fixed that now. Again, nice to be back live. I'm not going to do a long introduction like the first one. We're doing this live from the Adaptec Studios and the office, command center of everything event sourced and event driven in Vancouver. Thanks, Matt, for being here, and looking forward to a lot of these events. So do one more introduction of yourself, and then and we'll go from here.
Been involved with Adaptec for over the years. Learned as a client and now as a participant. Learned a lot about event sourcing, of course, from the source himself, Adam and Nicola. Along the way, I've come to realize there's a way to make event sourcing more accessible, more approachable. A lot of the terminology, a lot of the concepts for event sourcing comes from domain-driven design, and there's some really great ways of thinking about modeling systems in domain-driven design, but it's also a very object-oriented pattern, object-oriented paradigm. Whereas event sourcing all by itself and CQRS as along with it doesn't really need the infrastructure of domain-driven design, if you will. You can actually think about event sourcing on its own terms and build really great systems without having to think too much about things like aggregates. So I've created a product called Evently. We're just doing a preview release now, so trying to get the concepts about. I want to talk to you about what it's about. Some of the details about it is it's an online immutable event ledger. Now these specific terms mean it's online, and so it's a SaaS. It's not something you download and run locally or have to figure out how to run in Amazon or something like that. You basically, like Firebase or Shubabase, you sign up, you get a key, and you start using it directly. It's meant to be really easy to get going on. It has a REST API, which is designed for use by both client applications and server applications. There's some great products out there that use client libraries that you have to install and use, and you can only talk to the event database through the client library. And there's good reasons to do that. I want to make this more approachable so that you didn't have to have a lot of software to get to your event. So using standard protocols, able to create a simple API to express what I think are simpler concepts. So when you come from domain-driven design, or you're starting to learn about event sourcing, it was really tough for me to figure out what I didn't need to pay attention to in domain-driven design. And a lot of the difficulty in getting it, I think, stems from the fact that event sourcing wasn't really started as the first priority concept. It came a lot of it out of domain-driven design, or was picked up by that group. I mean, so if you think about event sourcing all by itself as its own information system, it can actually be a lot simpler to think about. So that's what I try to do with Evently, is represent a lot of the ideas in different terminology. I'll talk about linking them to things you may already know, but for the most part, if you come into event sourcing and you just know about these terms, you're still going to be very successful. You don't need to know all the other stuff so much. So, okay, so one thing when I talk to people at Evently, the first thing they say is, why would I ever want my client to do event sourcing? Like, that sounds like a crazy idea. There's problems with that. Like, clients, they talk to APIs, they talk to GraphQL, they don't do reductions, right? They shouldn't be sending events. And you're not wrong. If you took one of the open source databases and put it in your DMZ, you'd have a lot of problems because it's not where they live. They aren't designed to live in the DMZ for clients to access. However, there's a lot of good reason to think about maybe this is a great idea. So here's a traditional event sourcing architecture. On the left, you've got all the things that need to access the data and do provide actions to change the data. And I use the term actions instead of events, but they could be events, they could be API calls. You create this API that describes what your product is or what your service is. And then in CQRS, you'd split them into command handlers that accept a command and then pull events to hydrate to make a decision whether they're going to create an event from that, and you write the event to the event database. There's eventually, consistently, there's a view that picks it up and can present back the data. Processors can come along and react to those events, as policies or as process managers. They interact with the external system. So this diagram, I think, describes the basic event sourcing architecture that you're going to see almost all the time. There will be obviously variations, but for the most part, this is what you're doing. The main thing I want to call out is there's this boundary between the clients and the events themselves, and that's the API. The API exists really just to serve those clients. And what I've found is they're a lot of work. Like, you got to spend a lot of time building the API, controlling the API, keeping it in sync with the command handlers and the events and the views behind it. So one of the great things that Adaptec has worked out is innovated on is the concept of a slice. So when you build the software, you do all the pieces together as a unit of work. So you don't have this lag between the events that are possible or coming in and the API and the views that consume them and generate commands for them. So that slice organization really helps ameliorate this problem, but it still creates, because the clients don't talk to the events or don't send events and don't consume events, you still have to create this disintermediation component as does the API. So it's extra work to protect the event database from the clients is essentially how I see it. Another interesting thing is the pieces behind the API and the pieces that actually work with events are all pure functions. So pure function, computer sciencey wise, is it's a piece of software that you give it data, it has no interactions with any other system, and it produces data. So it's pure, it has no side effects.
Well, the way I would explain that is like f of x of y must always give z. Right? X and y are the only determinants of
It has no dependencies.
yeah, no other thing.
There's no dependencies, you can run the function a million times.
Yeah,
Yeah.
exactly.
Item-
X, y
item-
always
yeah.
give z.
It's idempotent.
Idempotent, yeah.
Yeah, I always say that wrong.
That's the way I learned that.
Yeah.
What pure function means. Yeah.
And it's what we've done. Our command handlers are all pure functions. Our view models are pure functions, right? Even the processors are half pure functions. I mean, they do create state, they do consume state from the outside world. That's their job. But for a lot of for the initial portion of it, they're reacting to data and they're producing data. So because of that, they don't really need to live on the server. There's no point of putting these in an Amazon container to run. The only reason you do it, again, is to protect the event database. So the idea is, because they're pure functions, what if you move those over to the client? What if you said, all right, you're going to have access to the events. The client can create commands. They can create remodels to make event decisions. they can consume events and create their own views. And the pieces that are processing that are not related to client actions, things like policies and process managers, those still live on the server, but they also access the same event pool, the same event database. And so you basically get rid of the API piece altogether, and you give your clients access to the events themselves. Now, there's problems with this. There's two main ones I've identified. The first one is access control. How can you be sure that those clients, which shouldn't be trusted because they're not trustworthy, how can you be sure that they're going to only access the things that they're allowed to access? They can see events they're supposed to see and no one else's events. I don't want Tim to see Eric's events because they're not the same people, right? That's not right. So how do I control access to that? When you're running command handlers and view models on the server, you can do this because you have one central point where you can put in your rules of controlling that. You also don't want state changes, events to be issued into each other's streams, right? You don't want Eric's actions to be able to affect Tim's events or Tim's entities. So the answer to this is not something I created. This is RBAC with attributes. This is a National Institute of Standards standard for managing data scoping. So what I'm looking at, I haven't built it yet, but this is where I'm going with this, would be you would actually say for each entity or aggregate in the DD terminology, you're going to basically apply a set of roles that are required. A good example of this is doctor-patients, right? You have a lot of patient information, let's say, but what you don't want is any doctor to see anybody's patients. So using RBAC-A, the attributes parts gives you ways to apply variables to the rules. You can say, Dr. Tim can see patient Eric's data, but Dr. Adam cannot, right? So you can give the attributed role to the right doctor for a period of time and see that that person can see. So using RBAC, you actually have a way. Sorry?
What about Dr. Drew?
Dr. Drew can see everybody. He's Dr. Drew.
So the idea is with Evently, what you've done is you're adding some role-based access control to the event source.
Exactly.
Right.
That's what's coming.
Okay.
Right. And so you would be able to describe, as an application developer, you'd be able to say, okay, these entity patient records, there's an owner role, right? And so Eric can see his own records, and he can authorize through events or whatever the API would be for another entity to access. So being able to identify the incoming calls is critically important to this.
So you can say that it has to be, so for instance, if I'm the person who's been authenticated, I can say the identity scope is somebody, it has to be me,
Yeah.
right? Like,
Yeah.
Okay.
And so, and applications do this already. There's companies like Ping that do that identity control.
Mm-hmm.
So part of this, I think the solution will be, bringing in an identity provider. There's so many of them, and using things like OpenID. I don't want to use SAML, but there's existing stacks out there, existing specifications and technology that can solve this problem. The big thing you would do with Evently is you would actually say, in addition to me telling what the entities and events are, I'm also going to say what the roles are. So I'm not inventing this, by the way. Firebase has already done it pretty well. Probably copy a lot of what they do, maybe not everything, but look for that as an inspiration of controlling, access to the database based on who you are as an API caller. So your API key would have the application key to access the system in general, and then an identity key to tell you who is actually accessing the data specifically. That's huge problem number one. I think it's addressable. Problem number two is data volume. So replaying all these events sounds kind of expensive, right? Do you really want to be sending over megabytes of events from one server to the clients out there? And my answer is, surprisingly, most people don't have those big of streams. Actually, it's not surprisingly. Good event design means you really shouldn't have 100 megabytes of events in a stream. That doesn't sound right, because it isn't right. You probably have it too broad. Another problem is, the assumption is you're actually going to need all those events every time.
Yeah.
There are cases where, yes, you do need the entire stream, but snapshotting is a big deal. Snapshotting is a way to store what you read. You don't need to read it again, you just need to be able to play catch up. So Evently has the tools you need basically to cache if you've already seen it. So I'm going to show this in a minute. But basically, if you get a stream back for an entity and then someone else asks for the same stream, product information is a great example of this.
Okay.
the internet's going to cache it for you. So we've already done
Okay.
things like e-tags.
Yeah, okay, like Akamai or something like
Yeah.
that, like that same concept.
Like
Do you have
CDN, sure, if you have a CDN, you want to employ that.
yeah, like a CDN, exactly. So do you have a concept of like per action, I only need these events coming back from the stream?
Yeah,
Okay.
yeah. So there's a concept called selectors I want to talk about, but basically every response will have an e-tag associated with it that's got events in it. And it also has safe cache controls. So safe cache controls mean the caching is public, but you have to authenticate before you can get access to it. So if it's possible to share that stream between more than one client, those two clients have to still go back to the server to say, hey, do I have the rights to read this stream? And then you can say yes, and the caching intermediary can then send back the stream without replaying it all out. And this goes all the way up to the client itself, right? So wherever it's cached along the way, if it gets evicted out of the browser, but it's in the intermediate cache at Amazon or wherever, it's going to get picked up and it's going to be streamed in fast. So that's existing technology for the last 25 years. We're going to use that because why not? It works great. Another big important piece of this is the data is shaped as is consumable by readable streams. So the examples that I'm going to publish, and I haven't made time for it yet, but they all use the browser's HTML5 readable stream. So when you use the Fetch API, you get your selector, your response for what events you want, you can stream it through a reducer, just like you would if you're on the server. You can do the same thing in the browser. So you're not having to load in 100 megabytes of events or a megabyte of events or any of that. You can basically pull it through one event at a time, and using HTTP, the back pressure will slow down the event stream if you need it to go slower. If it browns out or you lose your connection, the API lets you re-pick up the stream where you left off, so you don't have to replay what you've already seen. So if it's, because of the faulty nature of the internet, you go through a tunnel on your phone, it's pretty easy for you to pick up where you left off and keep on going with what you were reading before. So being able to catch up, use the stream API in HTML5 and caching, the data volume is still there, but I don't think it's big of a deal as people think. It's not a killer that's going to ruin the experience. If you create event streams that are huge, you're going to have to deal with that, but that's actually bad design. So for the most part, this isn't actually a problem. Okay, so some of the concepts that I was talking about. Entities are things that have state that change, and they change together. A lot of times, and this is always a hard part of event modeling, as you guys well know, is what are the entities? Using a process like event modeling is really cool because it lets you discover the entities as they relate to what your business actually needs them to be. So if you come into like the hotel modeling is a great example of this, and you try and find the objects right away, that's a mistake. What you're trying to do is, I just want to know what's going to happen, right? People call, they make a reservation, cleaners come, they clean rooms, and after a while you start figuring out maybe the entity isn't the room, maybe the entity is actually the hotel, right? Once you figure out what that entity is, now you have the thing that has state change applied to it. And so in Evently we call that an entity, in DDD you call it an aggregate root, sort of the same thing.
They have identity, or like have an ID.
Yeah.
Identifier.
They have an identifier.
They have an
You can tell
identifier.
one from the other. Exactly.
Yeah, exactly.
Or a shopper is another one you'll see oftentimes. Shopping cart is another one. Like, they're not that hard. But it is part of when you're learning event sourcing, this is that skill you have to get to as a developer to actually figure out what the entities are. The nice thing about it is it's usually a thing. And you can't split the thing in two, right? I can't split Tim in two and not go to jail.
It's a noun with an identifier, something like that.
Things happen to it.
Yeah.
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 The event registry is, before you can use an event in Evently, you have to tell us what it is. And this is mostly to fix fat finger problems, right? People misspell all the time. I do. And it'd be really terrible to create an application that puts in an event named, added to cart, item added to cart, and another one that puts in an event called thing added to cart. Well, those two events are probably the same thing, but the two different developers put in two different events. They didn't have this registry to help one of them figure out, actually, what you're trying to add doesn't exist. So you have to register events beforehand. Where this is going to go in the future will be, not only can you tell us what the name of the event is, you can also give us a JSON schema to tell us what it's going to look like. So JSON schema is a really cool spec because you can go from anything goes all the way down to super tight to where if field X is Y is 1, then field Y can only be 2. Like you can express super tight constraints all the way up to almost no constraints. So with this approach, you'll be able to, for events that matter, give us a data schema in JSON schema, and then we'll validate the events that come in. And because it's a registry, you'll be able to see what that schema is. So you'll be able to ask Evently as a developer, what is the schema for this event? And we think it's this. So that registry does help you make sure you don't make mistakes in the events you're sending in. Append styles, there's a couple different append styles. This is ways you can add events to Evently. And I'll go into those. We're going to go into event selectors. These are the things the concepts that let you get events out. And then we're going to talk a bit about the ledger itself and its architecture. Okay, append styles. There are 3 ways to put events in Evently. The first, most simplest way is just facts. You basically say, this is Kafka, right? Here's an event. It happened. It's usually for real world things, temperature measurements, package deliveries. There's no way to repudiate. There's no way to reverse a fact, right? It existed. Taco eaten. You can't uneat the taco. You got to do something different, right? So that's a fact. A lot of times, not a lot of systems, well, actually a lot of systems probably can use facts. They don't need anything else. The atomic one, I think, is the most interesting, and actually the piece that gets the most excited. It's a way of appending event that says, if these conditions still hold true, then write this event. And the conditions apply to anything in the ledger.
So could that pertain to workflows? So if I have a set of tasks that need to be performed, and let's say there's been a set of events per task, each task is its own action and outcome, and there's a set of them that need to happen for that to be atomic, and let's say if one of them fail, would you be able to revert that? Is that what you're kind of getting at?
I'll tell you what it is, and you go, maybe, but I don't think quite that complexity.
Okay.
What you can talk about the tail end of that.
Okay.
So like a good example is uniqueness. Like you can only have one entity with the username. The username has
it's
to
the
be
email. It's the first thing that people ask in the
the email
CQRS
address,
for.
yeah. How
Is
can I
that,
make sure-
make sure that eventual consistency doesn't allow you to ensure that you only have that one email address, that unique constraint.
Exactly. So this you'd say you can give it a selector and saying append this event only if no event matches this, right? And it can be no event matches, and when I get into selectors, it can get more powerful. You can say no event matches after this point, right? Another really powerful use is resource contention, where you want to reserve a concert ticket. This is the ticket master story. Everybody wants to go to, I don't know, pick your favorite band, but everybody wants to do it like right now. You can say reserve this ticket for my customer if no one else has. And because it's atomic, either you get it or you don't. And so that atomic guarantee means you don't have to have a bunch of compensation processors later that go look at the events and go, actually 2 people bought that seat, so we got to pick one of them to reject, right?
So it is kind of sort of, okay.
I think you could get there.
Yeah, with
Right
the
now it's a
workflows.
little simple, but I want to get to
No, but
where
it'd be
it's,
nice if like one of the tasks in a whole, set failed, you can have that and go, okay, well, this didn't occur. I want to roll back all the events.
those are transactions.
Yeah,
Something like
that's
that.
what I'm
That I
getting at.
don't have.
No, but that'd be cool with the atomic thing.
It would be
Yeah.
really cool, yeah.
Just putting that out there for you, yeah.
I think it's a great idea.
Yeah.
I think it'd be, I just
Something
have
to
chew
think
on it.
about, yeah,
Hey,
something to
Alex.
think about. Hey, how's it going?
Yeah.
We're recording.
Good.
So,
But anyway, keep.
that's okay, no, so this is the simplest form of atomic. Like you said, there's, I'm glad you're
Yeah.
sharing those ideas because that's exactly the kind of thing I think people will want to get to at some
Yeah,
point.
yeah,
And
yeah.
transactions are fantastic. I just haven't built that. The last type is serial. Serial is sort of the traditional event database style of append, safe append. So you're saying, I want to append this event into this entity stream if the last event is this event. So event store has a concept expected version. A lot of databases have like sequence numbers. This is a similar idea, except instead of having to know a sequence number or doing your own incrementing, you just say, the last time I looked at this entity, it was event X. And I want to append if there have been no new events in that entity since X. And if there haven't, you win. If there has, you get rejected. You replay that entity and you try again. So the typical compare and swap, that's there. And I put it in, actually, this is the first thing I built because I was used to this. I think it's valuable, but it's also really useful if you want to migrate an application to Evently, because this is what you probably came from. You could adapt to Evently, and then as you start learning more about, especially the Atomic one, start branching out and deciding I'm going to, some of these things I did in the serial model actually are more easy to understand as Atomic events instead. So it's a way to bridge to Evently. Okay, selectors, how do I get events out? There's two kinds of selectors. The first one is replay. The replay is mostly useful for command read models. You're basically saying, given an entity and one or more keys in the entity's types, so these are the IDs you're talking about, but in this case I call them keys, I want these event types. So in this request, I'm asking for all the game started and game done events on a game. There could be lots of other event types. I don't care about those. I only want these two. If I want all of them, I can just leave the array empty and it'll send back all the events. So it's up to you. What I found with commands and writing commands is, for the most part, you don't want them all. You just want a few of the types because you're trying to compute state for the specific purpose of what you're doing, right?
Yeah.
So you can really narrow down what you're asking for.
Like if you log in, you don't care about an address change so much, right?
Yeah.
Exactly. So you don't need to hydrate that event or bring that event back. Right?
Yeah. And if you're on a server and you're next to the event database, it's cheap to ignore events, so you don't really need it. But again, we're on the wire, and so you're going to pay a lot more attention to it. So having the ability to control which events you're going to get is really powerful. And what I found is having the ability to ask for more than one event key is also really powerful, because you may actually want to get a set of entity streams and process them. So instead of making multiple calls over HTTP, you can make one call and then consume them all at one time.
Wait, so how do you get the data, like how many games are in progress right now? Like with this, how would you get the data like that?
You may actually want this selector instead.
Yeah. That's cool.
So for commands where you're trying to change entity state on one entity, replay is really good. Again, it's also very familiar. The event selector that's a filter approach is much broader. So events have two aspects that you can filter on. One is the meta field, and the other one's a data field. Now the meta field in an event covers attributes that are cross-cutting, right? Like in this case, I've got actor. And so in my application, an actor is, the user that actually does things. And it could be, it could be a component, it could be whatever you want.
Yeah.
In CQRS systems, one thing you put in the meta will be the command ID or the causation ID. If you have a saga, you might do the saga ID or a correlation ID. You can put whatever you want in meta. The main thing is you shouldn't make specific data pieces in there. They should really be, entity scoped at least, if not broader, across the larger thing. And it's meta just because it's meant to be something you wouldn't discover in an events modeling session. But this is data you need to collect groups of events together. The data field is event specific. And so look at that, you can use emoji. I love that. You can make event names that are emojis, and any names are emojis. In this case, I picked the metal emoji, which I think is championship, something like that. So in my data, and I made it small because I don't need it so big on the screen. I want in the entity type of championship, I want for the championship created event, I want to look for players. So the data, this is a JSON path. I want to look in the players array for someone named Liz Wilkers. So I'm basically saying I want all the matches where Liz Wilkers has participated in. And so then it will give you back those events. In this case, the championship created. Of course, also applied by the actor is Matt Bishops, that's me. So you can mix and match. You can have multiple queries, so match created, match completed, whatever event you want to have, you can create these JSON path statements. Inside the JSON path statement, you can make, or statements. You look at the JSON. There is a specification. I did some documentation on the Evently website describing this language. So it's quite expressive. You'll probably find, for the most part, you're able to find whatever event you need to find based on the data sheet itself. These selectors are used to do the append as well for atomic appends. So the idea is you run a selector, you find what you want to find, and you make a command decision. I want to append this event if whatever I've selected hasn't changed. In which case you send that down. I'm going to show you how to do this in a minute. And then if it hasn't changed, it's quiescent, we atomically append that event. So the selector not only helps you find data, we can reuse what you created there to append data safely. Okay, demo time. Any questions before I do this work?
No, it's great. Did a great job.
Thanks, man.
Thank you.
Let me try and figure out how to switch to demo time. Okay, I am using,
A very small font.
yeah, let me
There's a view, go to view.
That's
there's
like
a
the first thing
presentation
people
mode.
complain about when they're out
Oh,
and
yeah.
stuff like this.
Go to presentation mode.
Oh, man, okay.
Yeah, there is a
Nice.
presentation mode. It bumps up everything.
Yeah, well, I know, but you want that, right?
Yeah, yeah.
Oh, there you go.
Yeah.
There,
Yeah.
Oh, look at this, okay.
Yeah, I like what they've done with that.
I
always hate
Because it
hunting for
happens,
the-
these things happen.
Hunting for the font size.
I like tools like Postman and stuff, but I love IntelliJ's HTTP. It's just so great. So I'm gonna run.
Yeah, so
This-
use that instead of Postman.
Yeah, I mean Postman's cool. I get Postman collections and scripts and all that. But when you're just trying to figure out what an API is and what you need to do for the headers and stuff, this to me just works great. So you get the root. You're gonna learn. It's what's called a level 3 or a hypermedia API. So you don't need to read a lot of docs to figure out how to use it. You can just start at the top, and there's going to be links in here to things like the registry I talked about, the append API, selectors, and then the ledgers, which I'll talk about in a minute more. But basically my point here is you don't need to go to the Open API spec to get started. You can just go to the root and start poking around. So if you want to go see, what does append do? I don't know what that is. I want to run. And then what's going to tell you is more documentation, and it's going to give you those 3 types. So you can append a factual event. You can, by following this link here, you can append a serial event or an atomic event.
So there's a reference to YAML as you're typing it.
This is JSON.
Oh, okay. No, but since you're typing the append, I saw there's a reference to YAML file, and it somehow knows like that. Yeah, event client API.
Oh, yeah, it's a good point. So I do have an Open API spec.
Okay.
Because I'm that kind of guy too. Because people do love their Open API specs. So this IntelliJ is aware of that in the project, and it can take me there if I really care. But since I know what I'm going to get, and it also, this is actually kind of a cool feature because it's going to tell me this endpoint has get and nothing else. Actually, it's got more than that, but I want to do the get. I think it's a
Well, but you
get.
say get, because you're beginning.
Oh, right, because I have said that. I was trying to figure that out as I was talking about what's going on. Okay, so basically, you can't, I'm going to run it, and then you're going to see basically a big fat JSON schema object that defines what form you would send. So if you don't know JSON schema, give this to your tooling, whatever tooling you use, whatever language you use, it's going to generate a type system for you if you want. Or you can learn what it is. And so in this case, you have to tell me the entity, the key, and this ref right here points up to what name string is. So basically it's a pattern of, the world in Unicode. You can name it anything at all, except I've locked out things like unprintable characters. So this is why you can do Unicode and emojis, because it's so broad as far as what a name can be. But it isn't everything, right? You can't send the delete character as an entity name. That's not cool. So then you also send in a key. The key is something that you create. So it's a business identifier. In your system, you may have an identifier generator, especially in enterprises. You may use hashes. This is your problem to solve, but this is how you describe that thing: the event name, the metadata, and the data itself. And data, because it's JSON, doesn't have to be an object. It can be anything. It can be a Boolean. So if you have an event and its data is true or false because it's a light switch, you don't need to create a data object. You just send true for on and false for off, and you're done. So the modeling can be as simple as you need it to be. So the API describes itself by just browsing it with your tool. You don't need to spend a lot of time reading the docs. But once you found it all, I'm going to go to ledgers a second and show you this one. You will have the ability to pull in some stuff. So one of the things you got here in the ledgers, we haven't talked a little about ledgers, but you can do two things with ledgers. You can reset a ledger and you can download it. So I talked about these are immutable. They are, but development ledgers, you do need to reset, right? You don't want to be able to like start at a known point, run some tests, do some development, and then reset it back and get rid of those events you created that are garbage or testable. So in some systems you can delete streams. Because of the way a ledger works, it's like a blockchain ledger. You really just can't delete stuff out of the middle. It uses continuous hashes through the events. So what I did instead is built a concept of reset. So you can reset it back to a certain point. In a production ledger, you're never going to do a reset. It can't work. So it's append only for sure in that one. But in development, not. Another thing you do is you can download the entire ledger. So this is a big problem people have as SaaS. It's like, well, the data, I don't have access to the data. And they're right. That's a terrible idea. But with Evently, there's a download link. You can get the whole ledger anytime you want. In fact, releasing a command line tool that you can script onto cron and download it every hour if you like. So it does have catch-up concepts, so it will automatically send what it already has and then pick up where it left off and pull in the rest of the ledger for a local.
So how do you deal with sensitive information like passwords, SIN numbers, or?
That's very, very good. I'm going to talk about that. That's important. I don't have a solution released yet, but there is definitely something I've been working a lot on, and I'm going to be talking to some people who know more about this than you guys all know. I can't say here, but more about it in depth. But the main idea I wanted to get across is you can get your data out, and it's easy to do. So if you don't want to do Evently anymore, or you just want to back it up because that's a good idea, it's not something you have to go ask us for. We're going to send you a CD. It's just part of your package.
I mean, you could have something on the back end as part of this engine that says, that's configurable, that says these property names are sensitive, and then you just don't send them down or something, right? There's ways to do that, man.
Yeah, I mean, I think it's the encryption is the key there, right?
Yeah,
so,
yeah.
But the short answer is, if you identify it as PII, when you download it, it's going to come down encrypted, and then in a separate API or a separate delivery, you'll get the keys. So if you do need to decrypt it, you can actually decrypt what you see there.
And I presume you can rotate those keys, right? So that maybe in the sense that like you get the data, but I don't know if there's a state. But I guess at the time you download it, you get a key. But if you download 6 months later, you may get a different encryption key.
Yeah.
And you can't
Yeah, you want to make sure that they line up, and you also for things like GDPR, you also want to destroy the key.
Right.
So if someone invokes a right to be forgotten, you still got the encrypted event in your ledger, but you can't read it. You can't re-identify the person from it. So that isn't built yet, but that's the direction we're going with this, is using those keys like that. Okay, registry we talked about. In this case, I've got a few. So this is what you can pull up and see. So I've got the game, I've got a match, I've got the player there, I've got the match created. Actually, that's a tournament and some thermostats. So these are some things I've been playing around with. Okay, I'm going to jump past to the register event because we've already seen that. But basically, before you use an event for the first time, you can register. This is idempotent or idempotent. You can do this every time. So in my tests, the first thing it does in the script is register everything it's going to test. And it's, if it's already there, it's a no-op. And that's just, basically the way the script works. Or we did the registry for this one. One great thing about an IntelliJ is you can do these expandos. So I've got environment files that are attached. So when I want to switch from like a local environment for development to the public one or some other account, I can use this, and I don't have to go in and edit things or expose my key to everybody tonight. So it's such a great tool. I love this thing. Okay, so I want to basically get the thermostat entity, and this is from the registry. What this tells you is it exists, and that's not interesting. But what it's going to tell you when you start adding JSON schema is what is the schema for this event. And this is really powerful for consumers because if they want to know what this thing is and what the kind of data they're going to get, you can tell them by registering a JSON schema. So then they can bring that into their own tooling and generate TypeScript interfaces or Java objects or C# things, whatever they need it to be.
One question for you is like we've been dealing with a lot of dynamic attributes in JSON validation schema. Would there be a way with that schema to add some of the keywords that are used for JSON validation schema, like email, min length, max length, that
Yeah,
sort of thing?
yeah,
Is that
exactly.
kind of where you're going
That's exactly
with
what it is. If it's a JSON schema, like draft
So you
7,
can add the
for instance,
validation part to it.
the validation is going to come in, right?
Yeah, great.
So,
Okay.
so if you do have min-max, right, or an enum or something, and you
Yeah.
send an event that doesn't match that,
Yeah,
it's gonna
exactly. Like a
reject the
drop
event.
down kind of would be like an kind of like, does it fit this
It'll
value?
exactly, yeah,
Okay.
it'll
okay.
control that. So not only does it validate events coming in, it'll give consumers who don't know, or you forget, because I forget, you know, what it's going to expect. So it's really easy to learn what the actual events are and what they can be. Okay, here comes a replay. In this case, I've got at the end of the game, this key I made up. So it's a, you know, a junk data generator. I want the game started and game completed. So now run this. I'm going to show you a little bit what you're going to get back. It does support cores. Right now, it's just using allow origin star, which is the, it doesn't care what the origin is, so where you're coming from. One of the things I want to do in a future version is let you control that access, so you don't have everybody. You can actually say it only can come from a website. Star is great for mobile apps, though, if they're going to have cores in their client. But this was, you know, this is something that's nice to have for browsers. Really, actually, browsers have to have this. Otherwise, you got to set up some kind of a proxy on your server to then proxy into Eventsly, and that doesn't make anybody happy. So here's the cache control and the e-tag headers. This e-tag basically is what you can use if you want to get it again, and if it hasn't changed, you go back at 304. So you've already read it once. It's got links to the different selectors. So there's one which is start, which is I want to replay everything again from the beginning. And another one is current, which is I want to replay everything after this. So if I have already processed all these events, I can take this link and just get it. I don't have to go through the post and all that. I can just get it. And it's going to send me anything new that's come back. Or if I want to restart from the beginning, I can start from the start. So doing this post of the form, once you've got one, you can start using these links to then manage that stream, the consumption of that stream directly without using post again if you don't want to. And then it's got a link to how you know, what the replay event looks like and what this is just guide markers to help you learn about it. And then what you get in this case, there are no events in this game. I think I reset it before I started. You got a selector ID, and you have a mark and some more links. What this shape looks like is there are no events, but it's going to give you a footer anyway to tell you it was empty. So this is valuable later. I'll talk about that in a second, why that is. What you can do is, here's the e-tag piece, right? That e-tag came. I'll grab this one. And so if you send this if none match with that, then you'll get back, oh, I'm unauthorized because I have a bearer token. Where's my bearer token? Actually, that's what I was going to show you. If I don't use the bearer token, even though the headers I sent down were cache control public, it still checks. So you still have to have access to the system, even though it's publicly cached. It's a nice feature of HTTP. Okay, if I do this, I can get back the 304. Response body is empty. Okay, selectors, I've got I think a bunch of events in here. If you want every event, you can do $. This is a JSON schema thing, which is just send everything. And so in this case, I will get all the events. Actually, there are no events because I reset it.
So $ is the symbol for everything?
Well, JSON schema has this as the root context of the object.
It's not like asterisks or anything, right?
Yeah,
For like wildcard.
It's like wildcard, but not quite wildcard. It's sort of like the beginning.
Okay.
So there's anything there.
Root, essentially.
Yeah, root. Yes, if there's a root, it's sort of the JSON true. Like
different way of.
if something is here, it's true, and therefore send it back. But as an idiot, I reset something earlier because I was testing, or I was trying to walk through this. Okay, But now one thing I want to show is the selector filter. So in this case, I want to register Adam Dimitric as a player in my system, but only if there are no other Adam Dimitrics. So I'm going to run this. I'm going to first check there are no Adam Dimitrics because I don't have an event here. So what I do is I take this data, this selector ID, and this mark, like this, if I can.
So what's Mark?
Mark is a place in the ledger that you read to. So the
It's like
selector,
a checkpoint?
It's like a checkpoint.
Okay.
The selector ID describes
So the mark
this
will always
query.
go up then. Like you always so if a mark is higher, you assume it's later.
If you're ingesting events, where are you at in your ingesting, right?
Yeah. So the selector ID describes the query. The mark describes where it was in the ledger that you read to. So if events occur after this, you're able to tell.
Right.
So I'm going to say my selector looks like this, and what I'm saying is if this selector has no new events after this mark, then register my friend Adam as a player in the game. So I'm going to run that, and voila, I've got this event ID right here. It's created. That's cool. If I try and run it again, I will get a failure. Race condition. There's newer events.
Oh, how forget going on.
And so you get it again, and you can make a decision, do I actually want to try and register again or not, right? And that's the atomic append in that case. I'm not going to show you facts and serial. I think they're pretty obvious, but for the most part, it should feel pretty simple. Like I said, you can reset the ledger. You can reset after, or you can reset the whole thing.
Actually, can you? I just realized maybe I missed the figure earlier. Always a serial. Like it's just what is it? I'm a little.
Serial is saying, I want to append an event in this entity stream
Okay.
if there are no events after this event ID.
Oh.
So like in like event stories say, append an event if the expected version is X, right? Instead of using version numbers, I'm using what you have in hand, which you probably have in your event stream, which is the event that you last read in the stream that relates to it.
Instead of keeping a number.
He's out keeping version numbers.
Instead of using version numbers, I've seen some events databases where you have to increment it yourself and then send that back.
Oh.
That seems like a really bad idea because for me, I'd be like, well, I'm going to increment by 1,000 because, you know, I'm that kind of guy. I want to be in, I want an event in there. So people can game a system like that. With this, you can't generate event IDs. You can't make them up. You don't know. You don't have enough information. So you have to use events you've actually seen to create that serialized append.
So what would be a practical use case? I'm trying to think of that. I'm just not getting the practical use case.
For
Like that feature that.
for a serialized append.
Yeah, I'm sorry.
That's kind of what I came to too, and it really is that compatibility layer. Like,
Okay.
because you're coming from an event database that thinks that way,
Mhm.
you can port your code
Oh, okay.
to Evently without having to rethink everything. It's a way to get started.
So it's more like if you're porting from existing event sourcing to there, that's the sort of way you can do it.
Yeah,
Right.
Yeah.
That makes sense.
but it's hard because the replay selector in a server-to-server event store or event database is going to be you're going to get all the events and you're going to have the last event or the last version number, and that's fine because you just dropped half the events on the floor, nobody cares.
Yeah.
But because you do care, you're using replay to select only the events you care about, the last event ID you saw probably isn't the most recent event in the entity stream, so it's not as valuable as a concept. But I mean, in the stuff I've written, I've used it in some cases. It's good for like, you're gonna run an ETL system, like a data loader,
Oh,
where
nice.
you wanna make sure you don't do
Mhm.
duplicate events like what append fact would do.
Right.
One thing I didn't show you is you can send an idempotency key with your event, which says, I'm going to push this event at you every 50 milliseconds till I get a success. And that's because I want to make sure. But what event would do, if you send that key, that idempotency key, it'll ignore everything
Right.
else, right?
So basically, you send the event 1,000 times the same as you send it one time.
Yeah,
Like there'll be no difference, right?
it's a one or more.
Yeah, if you have like
approach.
a processor that keeps going because something's down or whatever.
Yeah.
you can-
And you're on the
Yeah.
internet, so it's not
Yeah.
as reliable. There's no way to, the way
But
to
no,
say it.
that's like you can guarantee something happens once. You can't guarantee something like you're zero. You say it's either 0 or 1, but you can't also guarantee just one. You
Well,
may
I
get
have
it
a
in
question
one
for
form.
you.
Yeah,
it
so-
happens when the processor machine runs out of disk space, and you're checking for the existence of something having been sent in a log, and that log can't grow, but the logic still runs, looking for that. Oh, it hasn't been sent. I don't have it in the log. Well, yeah, the log can't increase, so
Oh, I
it'll
see what
never
you're
mark it
saying.
as done.
Yeah.
So every 5 minutes, you're gonna get this
Yeah.
publish of more and more things
Well,
that it thinks
even on
hasn't
makes
sent.
sense. Yeah.
even on queues, they would say like you guarantee get it once, at least once, but they'll never guarantee you only get it once. That's
Yeah, well, we talk about that in a lot of the
My question
Um,
to you
Yeah.
consistency versus being right and all that stuff.
is, so you're kind of taking some of the complexity out of the back end, right? You know, aggregates, etc., and the command handlers and the presentation layer, the hosting or whatever, right? So now what you're doing, you're saying, okay, here's this event store, software as a service, right? You're gonna get stuff back, and it's up to the client to do what it wants with it. So now, in order for the backend to get the statement of fact to record it, right? How is that handled? So like I have an action, something happens on a UI,
Yeah.
add this,
Yeah.
right? Like register user registered as the outcome. Is it all happening on the front end or the client, and
I
then
think
it's,
so, 'cause
and
that
then you're
command-
just saying, okay, this occurred, so now give this event to the backend. So you have like a way to ingest just events,
Yeah. Yeah.
right? You kind
So
of
your
see what I mean?
command handler would live in the browser.
That's what I'm getting at.
Yeah.
So what I'm saying is that does that mean that the business rules or the invariants that are used to determine when an action comes in, it should be blocked or not, are done in that, say, that client app? Because it doesn't necessarily have to be a browser, but that client
Yeah,
app,
it can
right?
be. I think it'd be in the client app.
So you're kind of taking that whole layer, like the command handler and the aggregate and stuff, and you're kind of moving it over to like the client side.
Exactly.
Right?
Yeah.
You're carving it out, moving it over here, and you're saying the back end is just like this event store with events, and then you're pulling them, you're filtering on them, and you're persisting them.
Yeah. Yeah.
Right? Is
Exactly.
that yeah?
Yeah.
Okay.
And with the append, one of the things that I think reduces that risk is if you append with the selector, if your business rules are off,
Yeah.
you've still got the selector to back up the quiescence. At least
That's what I'm
you're
trying
not
to
going to
get
have
at
two
is-
data matrix in the system.
Yeah,
The
like you
backline-
almost need a way to still kind of like in the back end honor certain rules, right? I wouldn't want to just accept anything from a front end, like any event that came in from the front end. You still want to kind of like guard that a bit.
Yeah, I think that's a security
I'm just
blanket
talking.
feeling. No, and I know, and it is something that I think is going to give people pause. I think it's one of those things where you're going to get comfortable with it,
Yeah.
and you're going to say, okay, because I have these controls, the access control stuff that's coming, I can use selectors to control the atomicity, whether I'm going to append it or not. The number of rules you have left on the browser get pretty small down to what's the state of the thing, right? So if it's a cart, and I want to add something to the cart, well, the command's going to say, well, if the state of the cart is closed, you can't add to the cart.
Okay. All
So,
right. So
like
then,
those kind of things, I think I'm going to see more interest in making the selectors more powerful. Or
okay.
you could have, like, here's a selector that collects an ID from like the cart created event, and then uses that ID in another selector to select certain events below it, right? So sub-selects inside of a select. That's what I've been thinking a lot about. So you could create in your statement, it's sort of like SQL, right? Like insert where, right? Those
okay,
statements
yeah.
are quite powerful.
Okay. And so
Because
my,
in your stream thinking, whenever we're doing event sourcing, we're thinking, okay, at this point in time, this is when the shopping cart got too full for what we can,
You only put
whatever.
50 things in it.
Yeah,
Yeah.
exactly. Or this is when the account has been verified. Like if someone's signing up, did they actually have an email confirm clicked, the button that they got emailed or whatever. And only from there do we look at any events after that. They may have updated their profile picture and all these other things, but we don't care. We only care to look for something after the account was verified.
Yeah.
So that limits what you have to
Limit
consider.
what you care about, right?
Yeah.
And one thing I've seen too is you're going to get events that shouldn't be there. It just happens, and that's not great, but that's reality. So part of your view models and your command processors is to be a little more graceful with dirty data, right? So if you're only selecting, has the cart been closed as your event to make a decision, but there's other events after that shouldn't be there, it doesn't really matter because the cart's closed, right? If you're doing a view that shows the cart, your business logic is okay, well, I'm going to show events that up to the cart closed. So if you've got crap events later,
yeah, sure. Yeah.
okay, it's there, but it doesn't hurt anybody, right? And that kind of resilience is what I think bigger systems rely on. Is it's okay if things aren't perfect, right?
I know where you're going with it, and my last question would be pub sub and integration with other systems. So the thing is like you can have an event store,
Yeah.
but like with you look with traditional event stores, they use they'll have their own baked in pub sub engine or something like that. So like let's say if I persist an event to your event lead, your event store, how can another system, like a concept of like external events, like integration types events, how can you tie into them? And because you have this client on the front end, sending the events to the back end, you're persisting them.
How do you see events occur?
Yeah.
How do you notify? So I'm going to talk about that in a second.
Okay, great.
That's a really, really important feature that you have to have.
Yeah, what kind of pub sub
Give me a
engine or
minute.
something?
I think I'm going to get to it, but I'm going to talk about the ledger for a minute. So the ledger is ACID. Now, ACID and relational databases is atomic, consistent, isolated, and durable. Isolated is basically transactions like you were talking about, where you say, when client X is doing transaction manipulations in the database over here, client Y doesn't see them until they commit. That's isolation. We don't have transactions where you're going to do event, then event, then event in Evently. So I changed the I to immutable because I think it's an important aspect of the database. So on the Evently website, I go into some detail about what these mean and why I make these claims. I think the isolated, when we think about transactions, that's going to be an important part of that too. So that you can make statements of atomicity across the transaction, commit, and then it would reject the whole if one of those claims fails because someone else came and made it.
Yeah, it's a good thing too, because then you can kind of avoid some of, like you brought it up earlier, you can kind of avoid some of those situations where you have to rely on compensation logic to rewind events that have been persisted when something failed in a workflow, right?
Yeah.
So if you can have some way of making it atomic so that you have task, and then one of them fails, well, guess what? If you have that something baked in there that kind of, before you even finally commit all those events for that workflow, you can avoid compensation logic.
I think the bigger ones for sure,
Yeah.
I think what I've got will be just enough for a single event in a single state. But I think you can extrapolate that. My concern will be, if it's highly contentious, would you want to have a lot of those? A lot of days transactions, they don't actually have more than 2 or 3. Someone who's going to do like 50 commits, or not commits, 50 statements in a transaction is asking for trouble, because that's a lot. That's a lot of stuff to do.
I just know, like, when you get into like microservice choreography across, like, hey, a workflow doesn't necessarily have to happen within one domain. It can be across many, right?
Exactly.
So then it's is this okay did this task happen over in this system, and this one, and this one, and this one? You get in this choreography. Like, it'd be kind of cool if, since they're all using that same SaaS Evently backend, you could do some pretty cool stuff, right?
Small period of time.
Yeah.
You just don't want it going over minutes.
No, yeah.
You want to have, okay, this, and then go.
Yeah.
But if it's holding up, because every ledger, every database out there, they have a point where it has to go onto a single writer. They just have to. There's no other way around it.
Yeah.
And so you don't want to hold up that single writer, or put your client in a position where a lot has been, put into the transaction and then it commits. I think the reality is it won't be a lot, but you want these 3 things to occur or not at all. Is what that would be. I think we can achieve that. It's just not there yet.
No, but it's something on your checklist of something
Yeah.
you can make happen.
And I really thought about doing, but it's just like you gotta, for me, it's like, we gotta get what you've got out.
Yeah, exactly.
And then have these conversations, because now I'm gonna learn, okay, what really matters is I thought it was this, but actually it's that. So that's what we're doing here. We did the demo. 2 slides left. One, I've talked about some of this. It's preview mode, so it's like the bare minimum. It's not even an MVP. It's the concepts that I've talked about. Most of them are there. It's free. You just sign up. The only requirements is don't put production data, don't put PII in there. Put fake data, please. You can get 100,000 events. I put a cap because runaway systems can go over the weekend. You forgot about it, and now you got 5 million events in your ledger. So if you need more, just let me know, and I'll grow your pool. But this is really just to keep bad things from happening automatically. So let me know. You can sign up online. One thing people always want to know is what's coming after this. So the big things I'm working on before we call it a product, and where there'd be some kind of a way to rely on this for an actual production system, are permanent ledgers. So ledgers that you can't reset. Once you've written, they're always there. Importantly, they would be homed to world regions. So I'm looking at around 20, setting this up so that you could pick among 20 locations in the world, like Sydney and Japan, or Tokyo, and Dulles, and wherever you'd want, not wherever you'd want, but within the 20. So you could say, my ledger lives there. And my data, so you can go back into the compliance systems that you have to participate in and say, my data at night rests in Germany. And that's a law for a lot of systems, especially in commerce. So being able to pinpoint that and not just say it's somewhere in the cloud is important. It's also important for locality and performance, right? Like right now, this is running on Heroku, it's running in US East, it's in Amazon, it's a 40-second, actually it's 80 seconds round trip between the two. That's the speed of light between here and Virginia and back again. So if you want that closer, then put it in Seattle if you need the physicality of it. So to be closer to your users for that. Multiple development ledgers. I think having lots of development ledgers are important for systems like that do QA, that do smoke tests, just creating their software. So everybody will have a ledger. You can have lots of these. I don't think we'll even charge for them. I'll just make new ones as much as you want. Of course, to a point, but basically I want to make it possible to create ledgers. One thing I'm looking at is doing merged ledgers where you could take one ledger and append to your own ledger, but get events from that other ledger. So you wouldn't be messing up. You could share like test data amongst all the developers, and nobody has to reset the test data. They can just reset their local version of it. So ideas around how to make ledgers developable across a team. Billions of events, I put the billions because I don't know what the limit is. But basically, because these are permanent, I'm saying billions. I think, ask me in a few years, this will be trillions, to the point where it'll be essentially infinite. And the nice thing about old events is most of the time you don't care. You can put them in cold storage. And so being able to do like a query plan where you can say, I want to run this selector, how long is it going to take? It'll tell you, I got to get a tape out of a hard drive somewhere. Right?
Yeah.
So the problems of forever we can solve. We don't have to solve them today, but it's something we're thinking about. User access controls you talked about, PII.
Yeah, that's cool.
This is important. I think you were I think you were saying, or Eric was saying, how do you make sure that you lock down the data so people can't see it? That is an important piece. So if you have to comply with the CCPA, which is the California one, GDPR, there's more that are coming, we want to give you tools to do so. So you don't have to roll your own GDPR compliance. You'll be able to specify, this is PII, and I need to get a report from Adam. He's asked how we're using his data. So through the API, I'll be able to pull out all the uses of it. And then Adam says, you guys suck, delete me, you tell me and I can delete Adam, and then from then on, who's Adam, right? But doing that in a way that you as an application developer don't have to think about, except how to use the compliance API. And the last one, selector push. So those selectors used to get events. The idea is, that I've been testing is, you resend it and you say, I want to subscribe now. And so then what it would do is it would notify you whenever a new event has occurred.
Yeah,
Oh,
you-
okay,
you-
so
you-
that's
you
the whole
need
pub
WebSockets.
sub kind of thing, yeah.
I think that's how that I will put that. I don't know if this is in order.
No,
but
it's
you
just-
need that,
But-
that would have been one of the big factors. Like
My
to
only
be able
thing
to
is,
say, push model, right? Like I'm sitting here, you tell me when event, because a lot of times, if I have to poll, that makes it.
no, I get it, Eric, but that the WebSocket, it's great for say like a browser or something like that. But I'm saying that what if you're in the cloud and you're like in Azure or something like
It's
that?
still good for servers.
No, but I'm saying have service bus, for instance, right?
Oh, I see.
What would be
Well,
nice
I
if there's a way I could hook into.
So I say WebSocket in air quotes. What I think is actually going to happen is it's going to have support for like the Socket.io protocol.
Yeah, exactly.
Their
That's what
WebSockets
I'm
and
getting
other things.
at. Yeah,
It's just the idea
maybe
is-
not use the word WebSocket, like,
Well,
'cause I
yeah.
think it's too like.
I think you're right. That's a good point.
Yeah.
I guess I use WebSocket because it's something that people in the
Well,
browser
you
space
say
call
client,
email.
right? What do you say client? I mean, nowadays,
Client
like,
application, yeah.
like 99, 95, like how many percent is web or web derivative? Even mobile devices would have used some sort of.
Dude, when you're in
WebSocket.
like when you're in the
Actually-
cloud though, dude, you have
actually,
different systems that need to integrate with each other. And if there's an event that happened over here, how do you get it? And some of these systems are using like Service Bus, or they're using some other, like in AWS, they have their own version of
SQS or something.
Yeah, SQS. So I'm saying is like having like the ability to notify. So if somebody hooked into that ecosystem, they could still get these events. So I'm just putting that out there.
Yeah, yeah.
And that's something that you can have like on your checklist, like, well, I got that support now, or like, in the future, right?
Well,
That'd be kind
announcing
of cool.
event bus on Azure. I think that's definitely an interesting area to grow.
Yeah, even event, the event.
Whatever makes sense, because you're going to have.
The reason I'm saying is because it's not that hard for a server to use WebSocket. Is Chrome client will use it was on the service bus, right? Like
Yeah, when you're on the server, yeah,
exactly.
for sure.
Yeah.
Yeah, I think there's you can use server sent events, right? Like that. So in my past life, I worked on actually a generalized push mechanism that whatever browser you're using. This is 15 years ago now, because it was so disparate. There was all kinds of ways of doing essentially the same thing, which is send messages over the internet.
You can just have different implementations and just say, I'm my like a config that says I'm supporting Azure, and then it's like swap it out, and then this is my external publisher, and you just dump it there, right?
I'm supporting.
Yeah, you could. That would be
We're
easy.
supporting
That could be
or
easy to
MQTT
implement,
or
yeah.
something, right? So whatever, more protocol oriented. So as the demand wants it. The key thing I want to point out though is, I don't think we're going to send you the event. I think we're going to send you that it updated. Your selector has new events. Because one thing I think with a client is, they don't want to get a whole. If this is a fast moving selector, they don't want 1,000 events coming every minute that they got to deal with. But they may want 1,000 little cheap notifications. That's okay, because there's
You could have the event type.
they're a
You could
Boolean
just
coming
do
at
event
them,
type, yeah.
right? Or we may send down the selector, the event mark. But basically, then the client has the power to say, okay, now I've got time, I'm going to run the selector that matches and get the events. Because what they could have done is, it's going to send the
Like
mark.
almost like a snapshot, like a checkpoint, and okay, yeah. Okay.
It's like the little beeper, hey, you have a new message, but it's not going to show you the message. What I'm thinking is, because you may have already fetched that, so the notification is going to have the mark, that ledger mark I was talking about, and so you can look, and ledger marks are sortable. So you can say, my current ledger mark is after the ledger mark and the notification.
What are you using for the like a GUID comb thing, or what is it?
No, it's I've got it on the website. I've got the declaration of it, but the definition of it. But I've got the event ID and the marker is a combination of a hash or a checksum of the event data and the event ID before it. The ledger ID, there's this thing called the ledger ID, which is your ledger versus your ledger.
Yeah.
And then it's got a monotonic clock. So the clock is a piece at the beginning that's using the sort. So it's the same. It's the same design.
It's the same as code as a GUID comb.
Is it? Okay. I know Google Comb. I know what. I took a lot of the design from Google's Spanner database. They have a monotonic.
Yeah. All these things are. GUID comb was kind of using a GUID or a UUID, but throwing away some of the randomness to put in the date timestamp as part of it.
Yeah.
Replacing it. And that if you wanted to use it for distribution, you'd have it ordered in this way, but you'd reverse the order if you want it to be sortable.
Interesting.
Yeah.
Okay, yeah, I don't know. I looked at like UID V1, which has a time component, but it didn't have enough accuracy. It was only 48 bits.
Hmm.
Which is I think up to, I think it's 5 seconds, and I wanted nanosecond accuracy, so I gave it 64 bits.
Yeah, I'm sure this was like well over 10 years ago now that I was doing that, and
think
GUID comb was the thing that was, at least in the .NET circles, was being used and talked about in the CKRS community. So
Yeah.
now no longer. I'm pretty sure there's with these spanner type
There's
of
other
databases, this problem has been investigated by way more smart
Yeah.
people at
Places
different
they
levels.
have to do lots of data. I mean,
Yeah.
Spanner is interesting because they offer a global SQL database.
Yeah.
The tricks they have to do, like there's a great video online, if I can find it, but they talk about when they make a new Google data center, they take the clock that's going to be, the time server for that data center, they take it to the National Time Authority, or what they're called, in Colorado, and they synchronize it. So you can bring your clock and synchronize it for a huge fee. But then they can't fly it. They got to drive it the same route every other clock takes to the ocean, and they put it on a ship and they sail it to where it's going to be. Because you take that clock and you put it 30,000 feet in the air, and in, I think it's 24 hours, it loses like 150 nanoseconds, which is a whole fucking lot of time in our day and age, right? So to keep them exactly accurate, they have to physically ship with, deal with the time dilation of gravity and do that. But then they also have this thing where, so the idea is, okay, you do a timestamp in Tokyo, and then you do a timestamp in Paris. You want to make sure that when you bring them together, they actually, but it's a transactional database with ACID guarantees. So they have all this fudging they do with the time, because they're sending each other their walls, right? Their write-ahead logs.
Yeah.
But when you do an append, it actually will sit there for up to 7 seconds until it's absolutely certain no one else is going to conflict with this thing. So Spanner has some interesting problems, especially large transactions, actually validating that it's a globally unique entry in the global database. This is why I like homed ledgers, because you're going to say, I can't see Tokyo from here, and for the most part, I don't actually care, because there's very little data that actually has that kind of time sensitivity that is not local. Most local data is time sensitive because it's created by local humans like us. But our data does not need perfectly synchronized with Sydney. Like, it just doesn't.
There are in some global company cases.
That's
but for the most part, yeah.
But
right,
the notion of time, the instant of time is actually an illusion, right? Like, just because you already know this instant in time is really, even to world half globe is not the same instant in time that you think it is. Like the notion of that, right?
Yeah, you can look at a calendar and get a nanosecond that's the same, but it's just it's different. Yeah, then this isn't gonna be for every single use case, but for most of them, most people are not gonna have this problem to solve, right? So a ledger that's got a location has a lot of business value in a lot of ways, especially because of legal things. Globally synchronized ledger is not a problem that I'm solving.
It's not. There are not many cases where that is that critical. And if you do need it that critical, maybe you need to use a different data set.
Well, you might need a different business model. I don't know. So, anyway, thanks everybody.
That was great.
Alright.
Are there any questions?
All right.
Yeah.
All right. No more questions?
No, I'm good.
Okay. Thanks everyone online that's watching, and people enjoying the recording in Europe. So sorry to the Europeans. The live events are going to be after work, Vancouver time. But recordings
You're welcome
will be
to come
available.
visit us.
Yeah, welcome back to the regular shows that are going to be.
Or we're gonna go there someplace.
That's
Yeah.
a better idea. I
Yeah.
like to say.
As soon as COVID restrictions.
I will try and do the Friday morning ones again as soon as I get more time and my book is finished. So thanks everyone. The stream is ended.
Good job, man.
That was fun. Yeah, thanks for being.